On the week we completed our mock exams, I've also reached 200 subscribers. How awesome. So I thought I should make a new video. It's been a while since I've had any requests, so after talking to a range of you this week in both Year 10 and Year 11, I decided the focus should be linked to the 30% of the GCSE that looks at applying maths. I hope you will find this useful. Remember, there are already some other videos to do with helping with your maths that are all on my channel, so make sure you also have a quick look back at those. There are 22 equations that you need to learn before you can apply them in your Edexcel Physics GCSE. You can find them all in Appendix 2 of the syllabus, and for my groups you will always find this in your homework resources booklets. Well, there's not really 22, because some of the equations are basically the same equation. These two and these two, they're the same thing. So let's say there's 20 equations to learn. And then, if you're doing the foundation tier, you've got one less, because you don't need the momentum equation. So you've only got to learn 19. You cannot build your confidence applying maths if you don't know your equations. The hard truth is, you need to work hard and put in the time to learn them, whether you want to say there's 19, 20 or 22 to learn. I'm going to try and help you with this challenge. Some equations are easier to learn if you think about what they're defining. Learning the key word first can help. Some equations you might find easier to learn from their units, so learning the standard unit first helps. When you're really struggling, making up something silly, or dare I even say a little bit rude, something that's personal to you as a memory aid, now that can help. When trying to learn all of them, card matching can work really well. You start with one set and then you build up. So if you aimed to add one equation per day, you would know them all in 3 weeks. But you need to start today. Some students find they've learnt all their equations and then they train themselves to be able to write out all the equations on one sheet of paper. Doing this at the start of an exam helps to give them a calming confidence. So, block 1, keyword equations. Acceleration is the rate of change of velocity. Rate basically means divide by the time taken. So acceleration is the change of velocity divided by time. Efficiency is all to do with the amount of useful energy you get transferred from the total amount of energy you put into a system. The good thing about this equation is, if you get a number bigger than 1, you know you did it the wrong way round. If you want to put it as a percentage, you just times by 100. Power is the rate of transferring energy. So power is the energy transferred divided by the time it took to transfer it. And that equation will work for electrical power too. As work done and energy transferred are the same thing, you could also say power is work done divided by time, or the rate of doing work. Now this is where Appendix 2 winds me up, because for me this equation should be voltage is energy divided by charge, because voltage, or potential difference, is the energy per unit of charge. And it's the same wind up with this one, because current is the rate of flow of charge. So current is the charge divided by the time. The last one for this block is density. Density is the mass per unit volume. The amount of stuff, the mass, in a certain amount of space, volume. So mass divided by volume. Next, let's look at a couple of equations where the units can help you remember the equation. I'm not showing my age. I have remembered I've done this equation, but it works here too. If you remember the standard unit for density is the kilogram per metre cubed, it will remind you you need to do the mass divided by the volume. Speed is measured in metres per second. Velocity, well, its size is measured in metres per second too. So that means divide your metres by your seconds. Metres is the unit of distance, seconds is the unit of time. So speed is distance divided by time, and that works for wave speed too. Higher tier only. This equation, for me, works best if you remember the unit for momentum is the kilogram metre per second. Mass in kilograms, speed or velocity in metres per second. Times them together. Mass times velocity, that will give you momentum. Now for the rest of the equations, you've got to get a little bit creative. You've got to come up with your own ways of remembering these. So I'm going to model a few for you. Some of them have been cut because Tom cringed too much. So I'll show you my highlights and then it's away to you. Do share with me any interesting ones you come up with. So imagine a warm, sunny beach with the waves lapping in as you remember that wave speed is frequency times wavelength. Weather sunny, feel warm. Energetic Fred has transferred so much energy, he's done so much work that he's done in. Yeah, I know, it's weak. Energetic Fred done. To remember, energy transferred is force times distance, but it's the same as work done is force times distance. Okay, they're honestly not getting any better, I get that. Springy frogs constantly explode. Get it? Spring constant is kind of in the rhyme. Yeah, okay, sorry. Okay, I'll finish with one more and then the rest are up to you. Killer eagles halve men viciously. Scared? You see, the halve as in half. Yeah, okay, I think you really can come up with better ones than me. Leaving you, force is mass times acceleration. Newton's second law is all yours. Weight is mass times gravity, whether that be gravitational field strength or acceleration due to gravity. But again, you can come up with a rhyme for that one. I liked my one for this. Margaret got hitched. Great party experienced. Apparently not. I'm sure you'll come up with a better one. What will you come up with to remember the moment of a force is the force times the distance from the pivot. We defined power earlier and linked it to work done, but for electrical power there are two other equations that you're going to need to make up a memory trick to remember. There's this one and then this one. Now remember, for this one, that's all to do with when you're wasting energy heating up the surroundings from the heating effect of current. Have you realised that we've reached the last one? I saved you Ohm's law to finish. V, voltage or potential difference, equals the current times the resistance. What will you come up with for that one? And that's all of them. They are all of the equations that you have to learn for the exam. There are the equations that you get in the exam that you just need to apply, but you don't need to learn those. Don't put off getting started. Start today. Learn one equation. Perhaps make your first set of cards. You'll be able to mix them up, sort them out, and keep doing that until you feel confident. Then tomorrow make another one. Build your task up. Each day you'll be able to train yourself and eventually you'll be able to write them all out. After 3 weeks, 5 minutes a day, you'll be there. Now, I could make a video about strategies for rearranging equations next. I could go over the triangle method, the flow method, that seesaw method, so you can choose which one will help you to build confidence. Let me know if this is something you want, but there's no point until you know your equations. Confidence will only come with purposeful practice, so don't forget all the resources that you have to help you with this. You've got your lesson booklet examples, you've got my Google Drive with all of those different examples from homework booklets and assessments in class. You have Eclair tasks, and then there is the Isaac Physics website, a brilliant resource for practicing your maths. Don't forget to
like,
so that I can keep making the videos.
comment,
Especially to request other revision topics.
subscribe.
So you can get notifications of when my next video gets uploaded. Regular review gets a better grade for you. Regular review gets a better grade for you.